Okay, today we're going to look at lesson 9. And your I can statement or learning objective is I can solve quadratic equations by factoring. So we have spent a lot of time on factoring. We did that before Christmas break. We spent a lot of time on it. And based on your all's grades in Math Excel on those assignments, you were pretty good at factoring. So whether you did guess and check or the star method or factored by grouping, whatever you did, it was successful. So we're going to use those skills today to help us actually solve quadratic equations. Okay, before we were just factoring, now we're going to factor and solve because those are two different processes. Okay, as always, I'm going quicker in the video than I would be in person, so feel free to pause and rewind, watch it at your own pace, do what you need to do. I do ask that you take these notes, write them down, work along with me through the examples, and then use this information to do your Math Excel work. Okay, so we can only solve for one variable at a time. So in order to solve for x, we have to get rid of y. So we make y 0. Okay, so we take our quadratic equation, we replace that y with a 0 or that f of x with a 0, then we can solve. Okay, so we solve for x when y equals 0 and we get solutions. Now we're making a little note here because as we finish out this unit and we start the next one, some of these terms are going to be used interchangeably. The solutions of your quadratic equations are sometimes called x-intercepts because they correspond with the x-intercepts of the graph of the quadratic. Sometimes you hear them referred to as roots, and sometimes you hear them referred to as zeros. Okay, but they all mean the same thing pretty much. So just know that. All of your quadratic equations have to be set equal to 0 to solve, and that's an important step, and we'll see how to make sure that happens when we start some examples. Here are some steps that we can follow to solve quadratic equations. First, you have to set the equation equal to 0. So most of the time it's already set up that way, but occasionally you could have a problem that's out of order, so you can move things to the other side of the equal sign and get it set equal to 0. Then step number 2, you're going to factor. Sometimes, or every time, you need to look for a GCF, but sometimes that's the only factoring you have to do. Sometimes you might need guess and check, the star method, grouping, etc. Again, whatever method you used previously back before Christmas break that you were successful at, continue doing whatever you were doing. And then number 3, set each factor equal to 0 and solve. So you're going to make little tiny equations after you factor and then solve those, and they're going to be very easy to solve. Okay, so now we'll move on to do some examples. Okay, so we're going to start with some fairly easy examples. So we have x squared minus 81 equals 0. This is one of our special case quadratics. So you should easily be able to factor that into x plus 9 and x minus 9, and that equals 0. Okay, so we factored it. That was, step number 1, make sure it's set equal to 0. That's true here. There was no GCF, so we factored it. 3, set each factor equal to 0 and solve. So x plus 9 equals 0 and x minus 9 equals 0, and you're going to solve each of those equations. So minus 9, so x equals negative 9, and then plus 9 on this one. So x equals 9. Okay, so you have two solutions. And that's because we have x squared. That is called that's the multiplicity. So that means that we have two solutions. Or actually, that might be a theorem. I can't remember right off the top of my head. But because that's a degree of 2, or an exponent of 2, then we have two solutions. Now, in Math Excel, I think it wants you to write it this way, negative 9, comma 9. But that's okay. You've got to do solutions like that before, I think, with absolute value. So just do both numbers separated by a comma. But we're going to do that same thing every time. So factor it, set them equal to 0, and solve. If you can skip this step and solve it in your head, that's fine with me. Okay? Number 2, pause the video, give this one a try on your own, see what you can do. All right, let's check it. So x squared minus 9, it's another special case. So x times x makes x squared. 3 times 3 makes 9. We need a positive and a negative to make that a negative. All right, set each factor equal to 0. All right, so subtract 3, get x equals negative 3. And on this one, we add 3, and we're going to get x equals positive 3. And those are our solutions. Okay, so again, we're following the same process. I think you have 1 or 2 problems like this in Math Excel, so you should be able to use those examples. Okay, number 3. I'm going to do this one with you, and then I want you to try the next 2 on your own. So if you look, this is not a special case. Look for a GCF. We have x squared and negative 14x. I can pull out an x, and that leaves me with x minus 14 equals 0. There's nothing else I can do, so I'm just going to set each factor equal to 0. So x equals 0, and x minus 14 equals 0. This one's easy. It's just 0 already. This one you add 14, and you get x equals 14. So there your 2 solutions are 0 and 14. And so here's something I want you guys to notice. And this can be a shortcut for you. So here your factors were positive 9, negative 9. So the solution to this was negative 9. The solution to this was positive 9. Those are opposites. 3 and negative 3, negative 3, 3. 0 is just always 0. But negative 14, positive 14. So your actual solution, as long as it's a one step and there's nothing in front of the x, it's just going to be the opposite of whatever you have there. Okay? Okay, I was actually wrong. Here's one more example like that, and I want you to try that one on your own, and then check your answer with me. Okay, so look for a greatest common factor. I can pull out an x, and I'm left with x plus 2 equals 0. Set them equal to 0. So x equals 0, x plus 2 equals 0. So my solutions are 0 and negative 2. Okay, again, and you could do the actual work there, or you can do the shortcut. Okay, so 5 and 6, they're similar to numbers 3 and 4, but they're just a little bit different. What do you notice? They're not equal to 0, so we're going to have to do a little bit of work to them before we can factor and solve. So I have 5x squared over here. I need to get this 45x to the other side. So it's a positive over here, so I'm going to subtract 45x. And that's going to leave me with 5x squared minus 45x equals 0. Now I can look for a GCF. So the GCF of 5 and 45 is 5. I can pull out an x. So I'm left with x minus 45. Negative 45 divided by 5 is negative 9 equals 0. Now I can set my 2 factors equal to 0. So 5x equals 0. X minus 9 equals 0. Now, this one you can do the one step if you need to. So divided by 5. X is just 0. On this one you add 9. And you get x equals 9. Okay? So anytime you have a coefficient in x or just x equals 0, that solution is 0. Okay? And when you have the addition or subtraction, your solution is the opposite. So pause the video, try number 6, see what you can do. All right, let's check your answers. All right, so we need to get that 7y to the other side. So we have y squared plus 7y equals 0. What can we pull out as a common factor? Y. We're left with y plus 7 equals 0. So my solutions are 0. And let's see, y plus 7 equals 0. So my y is negative 7. There you go. So those are pretty easy. You have problems like each of these in your Math Excel work today. So you should be able to use these examples to help you out there. Okay, number 7, we have x squared plus 10x plus 25 equals 0. Now, this is one of our special cases. You might not recognize it right off the bat, and it was a long time ago that we did those. So, we're going to keep the factoring trinomials pretty simple here. So we need factors of 25 that add to give me 10. I know that's going to be 5 and 5. So x plus 5 and x plus 5 equals 0. I set those equal to 0. And I get x equals -5 and -5. If I get the same number twice, do you think I have to write it twice? No, you can just leave it as x equals -5. Okay? Okay, this is another one of our special cases, and what I want you to notice on number 7, it was 5. Both of our factors were exactly the same. So that's that shortcut that we did where it was like x plus 5 in parentheses squared. Now, that's not super helpful for us with what we're doing right now, but that's where we got that shortcut. Okay, so let's do number 8. Pause the video, give it a try, see what you can do. All right, so we need factors of 36 that add to give me a -12. Well, I know 6 times 6 could give me 36, but I need to make them negative to get the -12. All right, so I'm going to have t minus 6 and t minus 6, and that equals 0. I know that these are exactly the same, so I really only have to do one. I'm writing out all the steps just so you can see, but I'll add 6. And I'll do the same here. So our t is just going to equal 6. Okay, so we still had 2 solutions on these. They just weren't unique. You can have 2 solutions and then be the same. That happens occasionally. Okay, 9 and 10 are very similar. We're going to do the same kind of thing. I went ahead and mixed it up on you just a little bit, just so you could see these steps and the factoring and solving all in one instead of doing a bunch of extra examples. So n squared is by itself over here. We need to get both of these things to the other side of the equal sign. So we're going to have n squared. We move -5n over, it's going to be 5n. We move over the -6, it's going to be +6 equals 0. Now we need our factors. Okay, we need factors of 6 that add to give me 5. So 1 and 6, 2 and 3. Which pair works? 2 and 3. So n plus 2 and n plus 3. All right, so now we set those equal to 0. So my solutions are going to be -2 and -3. You can put those in numerical order if you want to, but I think Math Excel will take it even if they're backwards. I think that's fine. Okay, number 10 is very similar, but what do we need to move over to the other side? 36. So we're going to subtract 36, and we're going to match it up with this 81 because they're both just plain old numbers. Okay, so x squared plus 18x plus 45 equals 0. And then let's factor. So we need factors of 45. So 9 and 5, 1 and 45, 2 doesn't work, 3 and 15, 4, 5, 6, 7, 8, 9. All right, could one of those pairs give me 18? Yes. So x plus 3, x plus 15, set those equal to 0. And our solutions are -3 and -15. Okay, we have one last example here. You don't have any like this in Math Excel, but I just wanted to show you what it looks like just so you're familiar with it. So 3x times the quantity x minus 3 equals 5x squared minus 10x. So I'm going to start by distributing and get 3x squared minus 9x equals 5x squared minus 10x. I need to get all of this together on one side. So I'm going to subtract 5x squared and add 10x. Those are going to cancel, and I'm going to have 0. 3x squared minus 5x squared is -2x squared. -9x plus 10x is just x. Okay, then from there, I can do some, I can factor out a GCF. and solve. So I can pull out a negative x, and that leaves me with 2x plus 1 equals 0. And so negative x equals 0 is just x equals 0. 2x plus 1 equals 0. I subtract 1 and get 2x equals negative 1 and divide by 2 and get x equals negative 1/2. So on this one, my solutions are negative 1/2 and 0. Okay? And so you can get fractions. You can have more complex quadratic equations. We're trying to keep it simple right now just as we practice the factoring. But when your problems are easy to factor and you're just finding the two numbers that multiply to give you the one on the end and add to give you the one in the middle, those are really, really easy to solve by factoring because essentially once you find your factors, your solutions are just the opposite. Okay? Now, I do want to talk about one other thing before you go do your Math Excel work. Okay, the factor theorem. It says if x equals a, then x minus a is a factor. So it's kind of going backwards from what we just did. We took the factors and then turned them into solutions. But you can go the other way. If you find out that x equals negative 5 and 7, you can turn that into the factors x plus 5 and x minus 7. Okay? And then you can even go further backwards and create your quadratic equation or quadratic function. All right? If I gave you y equals 4 and 9, you saw those are solutions to a quadratic equation. What would your factors be? Y minus 4 and y minus 9. Okay? What if I gave you q is equal to negative 7 and 0? All right? So negative 7, that would be x or q plus 7. And then to get 0, it can just be a q. Okay, so you can work backwards. If you know the solutions, or the x-intercepts, the zeros, the roots, you can work backwards to factor. Okay, and we're going to talk more about that in another lesson that's coming up soon. All right, so here are your examples. If you need help, please let me know. I would be happy to assist you any way I can. But use these examples to help you on your Math Excel work, and have a great day.